All right, good morning. If you can hear me and see me, give me a thumbs up in the chat box. Somebody just say, hey, you're good. If you can hear me and see me, somebody say something in the chat box. Thank you. All right, very good. Let's jump into this. Today we're doing 5.5 notes. Any questions over 5.4 notes? Before we go there, any question over five? Or I said 5.4 notes. I meant 5.4 homework. Any questions over 5.4 homework? Hey, good morning, guys. Good morning, Taylor. Good morning, everybody. Taking any questions over 5.4 homework right now. If you have any questions, type them into the chat box. Be glad to answer anything for you. All right, seeing no questions, give me a thumbs up if you got 5.5 notes out and you're ready to go. Oh, Taylor with the late question coming in. All right, hold on. Let me answer Taylor's question about number 8. Okay. All right, so number 8. If we work that out, what we're going to do is we would subtract 2 from both sides. Cancels, and I get the square root of 2b minus 5 equals b minus 2. Okay? Then what I have to do from there is square both sides in order to cancel the square root and the square. Now I have 2b minus 5 over here. And then I have to square that side as well. And that, of course, is b minus 2 times b minus 2, which is FOIL. So this 2b minus 5, which canceled, came from this. And now I got to FOIL this. So first is b squared. Outside is negative 2b. Inside is negative 2b. Outside is last. So 2b minus 5 equals b squared minus 4b plus 4. Should look something like that. And then what I want to do is subtract 2b from both sides and add 5 to both sides. Cancels, cancels. 0 is then equal to b squared. Now I'm going through it kind of fast because I assume you have some of it. Minus 6b plus 9. And then what will multiply to be 9 but add to be negative 6? That should be negative 3 and negative 3. So b minus 3 and b minus 3. That's a perfect square trinomial when you have the same. So then therefore b minus 3 is equal to 0, and then b is equal to 3. Now you don't have to say this is a multiplicity of 2. That's only when we're dealing with graphs. So you wouldn't have to say that's a multiplicity of 2 since there's 2 b's. It's just simply b equals 3. Okay? So, are you good on that, Taylor? Very good. Okay. All right. Any other questions on 5.4 homework? Any other questions on 5.4 homework? Seeing none. Okay. let's go to 5.5 notes, get that out, and we'll be ready to go with that. All right, so jumping in here to 5.5 notes. Now, I don't know I really don't know why this falls in chapter 5, this whole function operations, because chapter 5 is all about radical, where we have, a fraction. Again, like we had like on your homework yesterday, you have a fraction as an exponent. But for some reason, they put function operations in here. So we simply, we will simply just work this one. Not as much to do with like radical exponents, but it does play a very important role in algebra, and it's just your ability when you're given two functions that you can operate within those. Okay. Now, anytime you hear the word operations in math, you just simply need to think multiplication, division, adding and subtracting, squaring, stuff like that, okay? So those are all operations. So that's what we want to do here is we want to operate when given two functions, okay? This is actually looks pretty simple, and it actually is pretty simple, all right? So let's start with number 1. H of t is equal to negative 3t minus 5, and g of t is equal to 4t minus 3. It says find h plus g of t. So here's what we're going to do, guys. Literally, we're going to say negative 3t minus 5. That's h of t. And then plus g of t, which is 4t minus 3. Take myself out of the camera just a little bit. Okay. And then from there, we just combine like terms, guys. So from there, we combine like terms. I have negative 3t and 4t, and negative 5 and negative 3. So negative 3t plus 4t, okay? Negative 3t plus 4t is simply just t. And negative 5 minus 3 is negative 8. And that right there is our answer. We have found h plus g in terms of t. So pretty simple there, guys. All right. Now, let's jump over to the next one. So it says, gives us two functions, h of n, g of n. It says find h plus g of negative 5, okay? So same process here. Let's do that. Negative 4n plus 5, and then plus the other one, 3n plus 2. But now notice this case. Over here it had h plus g of t. Over here it has h plus g of negative 5. Okay? So it wants us to find h plus g in terms of -5. So what that means is that we're going to plug in -5 into every single n. Okay? Now, you have some options here. You can combine like terms and then plug in -5, or you can just plug in -5 from the beginning. Okay? I'm going to just plug in -5 from the beginning because when we get down here to these lower problems, you're going to be like, okay, it would be best that we would just go ahead and plug in -5. So -4 times -5 plus 5. Now notice the only thing I've done is plug -5 into the n. Plus 5 plus 3 times -5 plus 2. Then we just do some math here. -4 times -5 is 20. 20 plus 5, and then right here, positive 3 times -5 would be -15, and then plus 2. $20 plus 5 is 25. And then 25 minus 15 is 10. And 10 plus 2 is 12. You get the same thing if you were to combine -4 and 3 and then go from there. Okay? You would get the same thing. Give me a thumbs up if that makes sense. Give me a thumbs up in the chat box if that makes sense, guys. Just kind of making sure you're still with me. Following along good. Got 14 people here today, so looking good. Good Adam, good Tara. Good Kenny. Good Maddie. Good Karen. All right, good Andy. So jumping down here to number 3. G of t equals 4t. H of t is equal to -3t plus 4. Okay? So G of t is equal to 4t. H of t is equal to -3t plus 4. So what we're doing here, guys, is the same thing, but now it's minus. Now keep in mind that minus is going to play a very significant role here. Okay, remember, anytime you're dealing with subtraction and you're subtracting two things, always be careful. So here we go. It's 4t minus, and it's this whole thing, the quantity of -3t plus 4. So make sure you remember, anytime it's a binomial and you're subtracting something, you have to put it in parentheses. Now, if it was a monomial, just one term, then you could just drop it down. But with it being a binomial here, two terms, you have to put it in parentheses in order to do this right here, distribute. So 4t plus 3t minus 4. So that negative actually changes their signs. And we simply have 7t minus 4. Can't combine those, they're not like terms, and it said to solve it in terms of t. So I solved it in terms of t. All right, number 4. F of t equals 2t squared plus 2t. G of t is 3t minus 1, and it says find f minus g of -1. Okay, so here we go. We got 2t squared plus 2t minus, and since that's a binomial, two terms, we're going to have to put in parentheses, 3t minus 1. So we're saying it's not just minus 3t, it's minus g, and g is 3t minus 1, so we have to say minus the whole thing. So let's go ahead and take care of that. That's 2t squared plus 2t, and then minus 3t plus 1. So the only thing I did was just distribute the negative and got negative 3t and positive 1. It changes their signs. Okay, and then what I need to do from here is take a look at this. I'm solving it in terms of negative 1. So I need to plug a negative 1 into all the t's. Okay, plug a negative 1 into all the t's here. So 2 times negative 1 squared plus 2 times negative 1 minus 3 times negative 1, and then plus the 1 right there. That 1's coming from here. So again, I've just plugged in negative 1 to all the t's. Negative 1 times negative 1 is positive 1. So, and then 1 times 2 is just simply 2. And then 2 times negative 1 is negative 2. Negative 3 times negative 1 is positive 3. And plus 1 at the end. Two minus 2, simply 0, and then 3 plus 1 is 4. Notice here that when you're solving for terms of a number, you're going to get a number. When you're solving in terms of a variable, you're going to get an expression. Okay? So over here, you're going to get a number. Over here, you're going to get an expression. It just depends on what you're solving for. So that's addition and subtraction. Give me a thumbs up if you feel good about that. That's addition and subtraction before we go on to multiplication and division. Good, Maddie. Good, Tara. Good, Adam. Good, Molly. Good, Kenny. Good, Taylor. Good, Andy. Good, Chris. Good, Jesse. All right. So, from there, we continue on. All right. Looking at number 5. So, number 5 says f of x equals 4x plus 5 and g of x is equals 4x minus 3. It says find f times g of x. Okay, so we're going to keep it in terms of x here, and here's what we're going to say. 4x plus 5 times 4x minus 3. That would be multiplying f times g. Now this is a binomial times binomial, so what's that acronym we're going to use when we're multiplying a binomial times a binomial? Very good, Terry. FOIL. Good, Molly. FOIL. So we go first. 4x times 4x would be 6. Good, Maddie. Good, Chris. 16x squared. And then go outside. 4x times negative 3 would be negative 12x. Inside, 5 times 4x would be 20x. And 5 times negative 3 would be negative 15. From there, we just need to combine the middle two terms, 16x squared, and then negative 12 plus 20 would be positive 8x minus 15. Now, again, looking at this right here, it's in terms of x, so that means I just had to multiply it. I didn't have to plug in anything. So that would be my answer there, 16x squared plus 8x minus 15. All right, jumping over here to number 6. So it's still multiplication. And it's f times g, so I say 4x minus 2 times x squared plus x. Okay. Now, here's what that says. It says to multiply that. Okay. So here's my question to you guys. Should we go ahead and FOIL this? Or should we just plug it in? FOIL it or plug it in? Should we FOIL this and get like an expression like this and then plug -3 in, or should we plug -3 in right now? Tara says plug it in. Taylor says plug it in. I agree with you all. If you go to start foiling this, you're going to get in a lot of x's, okay? So it's just best to plug it in now. So 4 times -3 minus 2, that's plugging -3 into this x right here, guys. 4 times -3 minus 2, and then times -3 squared plus -3, and that's plugging -3 into these two x's. Four times -3 is -12 minus 2, and then -3 squared would be +9, and then plus minus would just simply be -3. Now here's the thing, we don't have to FOIL this because these are numbers. We can, order of operations says use parentheses, so we can actually do parentheses here. So what's -12 minus 2? That would be -14. And then 9 minus 3 is 6. Then therefore, -14 times 6, well, 10 times 6 is 60. 4 times 6 is 24. So it should be -84. Confirm that with a calculator real quick. 16 times 4 is, or 14 times 6, sorry. 14 times 6 is 84, and it's going to be negative. Give me a thumbs up if you're good for multiplication. So that's multiplication of functions. Good Tara. Good Kenny. Good Maddie. Good Taylor. Good Chris. Okay. Slip it down here to the division of functions. So let's divide them now. G of t is equal to 3t plus 2, and f of t is equal to 3t plus 2. It's g divided by f. So we say 3t plus 2 over t cubed plus 2. Now, this is in terms of t, so I'm not plugging anything in. But can I simplify? Can I combine anything? Can I factor out anything? Can I do anything? Can I cancel anything? Can I do any of that? Can I cancel the 2's? Can I cancel one of the t's? What do y'all think? Someone type in the chat box. Or is that our final answer? All right, Tara has a good idea. She says you can factor out the t and the 2 will cancel. If we were able to factor out a t, in order to factor out a t from the numerator, the 2 would have to have a t. Same thing in the denominator. In order to factor out a t here, there'd have to be a t here that I could factor out. So I can't factor out a t. Good idea though. Good guess. Anybody else? Okay. That is our final answer. Nothing we can do. We can't factor anything out. We can't cancel anything. We can't cancel the 2's because they're attached with another. They're a binomial. So we can't just cancel those out. Can't factor anything. So that is our final answer there. Okay? Very good. Looking at number 8. G of t is equal to 4t minus 4 and f of t is 3t cubed minus 3t squared. Find g of f of negative 3. So again, it's g divided by f. So g is 4t minus 4 over f, which is 3t cubed minus 3t squared. We actually could factor some stuff here, but there's really no point into it because we're solving it in terms of negative 3. So what we need to do is just simply plug it in. So here we go. We got 4 times negative 3 minus 4 over, now this is going to look a little crazy here, 3 times negative 3 cubed minus 3 times negative 3 squared. So just plug in, simply plug in negative 3, guys, in for that t and that t to get us to looking something like that. Let's clean it up. So we say negative 12 minus 4 over 3 times, or let's first handle this. Negative 3 cubed. Negative 3 times negative 3 times negative 3. It's going to be a negative, and it's going to be a negative 27. So 3, don't forget about our original 3. 3 times 27, and then minus 3, and then times negative 3 squared is 9. And actually that's a negative 27 in there. Make sure you put that negative, sorry. But that's a positive 9 because negative 3 times negative 3 is positive 9. But over here, negative 3 times negative 3 is positive 9 times another negative 3 would make it negative 27. Negative 12 minus 4 is negative 16 over, that would be negative 81 minus 27. That would take us to negative 16 over 108, negative 108. And then we just ask ourselves, what can this be simplified? And it can, but by what number? 16 won't go into it. What's the best number to go into that? Looks like 4 will go into both of them. 4 will go into that 4 times, and it'll go into that 27 times, because think about 4 will go into 100 25 times, because 4 quarters are 25. That'd be $1, but then 2 more would be 27. 2 more 4s would be 27. And it's going to be positive because a negative divided by negative is a positive. Yeah, no, Taylor, you're fine. 2 would actually work as well. You would just simplify it again from there. And eventually get 4 over 27. All right, give me a thumbs up on the division part. So pretty simple stuff, guys. If you can simplify it, simplify it. If you got to plug it in, then just do all the work. Be very, very patient and peculiar with the work. All right, very good. Jumping to the back side. Now, the back side introduces another concept of functions. So for some reason, I meant for this right here to go down here, but it did not. So I need to scoot the paper up. Okay, I need to scoot the paper up so I can I'm going to write some notes down here. Okay, going to write some notes down here. So again, just to kind of, here's like number 11. Here's number 11. So I'm just going like, a little bit below that, probably around right here. Okay, just so you kind of know the amount of space to kind of leave there. All right. So, and I'm not actually, I actually do take, I know you may see some, looks like some blue dye there. I know it may look like, I don't wash my hands, but I do wash my hands. Oh, I'm sorry, I didn't have it in the camera. I have some blue dye right there on my, I still don't have it in the camera. There we go. Oh, yeah, there we go. You may see that blue dye there. I'm actually redoing my lawn. And in the process of doing that, I got these chemicals off eBay. Could be sketchy, could not 100% sure. But I did order some chemicals off eBay. They say the professionals use this, and they say it's the best stuff out there. But because if you spray too much of it, the problem is you mix it with water, you go out there and spray it. But if you mix too much of it, and you spray too much of it on the grass, it not only kills the weeds, which is my objective here, is to kill all the weeds, but it also kills the grass with it. All right. So they say you put this this blue dye with it, and the blue dye, which you obviously see right there, kind of on my finger, that it kind of got in that bed of there. That blue dye helps you see where you're spraying at, so you're not overspraying it. Because if you overspray, it will literally kill all your grass. It's been about 2 days since I've sprayed it all. They say it takes about a week to go into effect. So all my grass could be dead, or all my weeds could be dead. But one thing is for sure, I did get it all over myself. But unfortunately, that blue dye got stuck in there. So just a nice story for a change of scene there. All right. So now what we're doing is what we call composite functions. Okay. So composite functions. Now, what composite functions are, if we look at the beginning of the word composite, which the root word of that is compose, would mean be able to put together. Okay, we are putting together functions. All right, so composite functions, the result of applying the rule for one function to another function. Now that probably makes no sense to some of you, but that's all right. I'll kind of explain it. That's the more your book definition. And we're going to see this little symbol. It almost looks like a degree mark, but it's between our functions, okay? Like number 11, you can look, it says find f, and it says O, and it looks like a degree mark, G. And that just is an operation. This just represents an operation called composition of functions. So this literally just simply means, the way we would pronounce it, we would just simply say compose. So if we have something that says this, if we have something that says F composed with G, looks like the word fog. Just wait, next chapter we're going to learn about a log. So here you're learning about fog. If you see something that says fog of X, that simply means this, guys. Plug G into F. So it looks like this. F of G of X. Okay? Likewise, the other way, if it was GOA or G composed, again, that we read that composed, G compose H of X, we're going to put H into G. And that would be simply G of H of X. So we're putting H of X into G, putting G of X into F. So that's kind of that. Now let's go back up here. That's kind of the explaining what we're doing. These are called composite functions or composing function, another operation of functions. Okay? So, looking at number 9. So here's what it says. 3x minus 4 is g of x, and h of x is 4x plus 4. Okay? That's what we're working with here. All right? So literally what we're going to do, guys, notice here, it's g composed of h of x. Okay? So plug h into g. So it would look like this, g of h of x. Think about it like that. We're putting h into the x of g. Okay, so I have g of x, which is 3x minus 4. I have h of x, which is 4x plus 4. So I am putting h into g, okay? So I'm going to put this h right here, whatever h of x is, into the x of that. Now, if that had more than one x, I would have to put this h into all x's, okay? But with it just having one, I'm just going to put it in the one. But like, let's say that there was like another x squared here, I'd have to put that 4x plus 4 into that x as well. So you have to put it in all x's. So then from here, here's what it looks like. 3 times the quantity of 4x plus 4 minus 4. And then from there, guys, we're just simply solving it. So distributive property, 12x plus 12 minus 4. 12 minus 4 is 8, so 12x minus 8. Oh, I'm sorry, not minus 8. I'm surprised when you didn't jump on me quicker. plus 8. Sorry, 12 minus 4 is positive 8, not minus 8. Looking at number 10, same thing. Look at what we're doing. We're putting H into G. Putting H into G. Okay? So I have G of X is negative 2x minus 2. H of X is 3x plus 5. So we're putting H of X into the X of G of X. So G of X is equal to negative 2 times 3x plus 5 minus 2. Now again, if there was more than one x over here in G of X, I'd have to put that in each one. But since there's just one, I just plug it in the 1, and then I simply solve from there. All right. From there, I just distribute. Negative 6x minus 10 minus the 2 right here on this outside. So that's negative 6x minus 12. And that would be our final answer. Give me a thumbs up if this is making a little bit of sense to you. Give me a thumbs up. Everything making sense? We're just plugging H into G and then solving. Good, Terry. Good, Adam. Good, Andy. Good, Maria. Good, Maddie. All right, jumping down here to number 11. F composed with G. Put G into F. So F of n is equal to 3n minus 5, and G of n is equal to n squared minus 5n. So we're putting G into n of this. Putting that right there, guys. So this would read 3 times n squared minus 5n minus 5. I then distribute. 3n squared minus 15n minus 5. Now, I know some of you be like, well, hey, do we factor this? Look, it's not an equation. It just says find this in terms of n. So that right there will work. Last one. F composed with G, put G into F. Okay, put G into F. 3n squared minus 3 is F of n. G of n is 2n plus 4. So take this, put G into the F, or the n there. So it'd look like this. 3 times 2n plus 4. But now notice that n had a squared on it, so we're going to have to square that. And then minus 3. Now, don't let this one trick you. Look what you're solving it for in terms of -1. Now, if we weren't solving it in terms of -1, we'd have to FOIL that, okay, because it's a binomial and a binomial. Very good, Terry. Yeah, so that's what I was talking about, that -1. So it seems that we'd have to FOIL that, but we don't have to FOIL it because we can just plug in the -1. So it's 3 times 2 times -1 plus 4 squared minus 3. So because we're solving it in terms of -1, we don't have to FOIL this and solve for n. We can just plug it in. From there we get 3 is -2 plus 4 squared minus 3. Then from there we got 3, and we would have here that -2 plus 4 would simply be 2 and squared minus 3. 2 squared is 4. 3 times 4 is 12. Make sure you use order of operations. And 12 minus 3 is 9. Sorry about that. Okay, and that completes that. All right. Now, looking at your homework over here, I wanted to show you one that what I'm kind of referring to. Okay. And that's number 10. So if you have your homework, look at number 10. So again, it says to put h into g. Okay, and solve in terms of n. So g of n is equal to n cubed minus 5n squared, and h of n is equal to 3n plus 4. Okay? So you actually have to plug this right here into both of those. And then you would have this right here. 3n plus 4 cubed minus 5 times 3n plus 4 squared. Now you're not solving this in terms of anything, so that means you're going to have to FOIL that and then use the rows and column method, because after you FOIL it, you're going to get a trinomial, and then you're going to have to multiply it again by that since it's cubed. Over here, you just have to FOIL that, and then whatever your answer is, distribute a -5 in. Okay? So just trying to set you up for this problem. I'm not going to show you how to do it now, but try to figure that one out. All right? Try to figure that one out. Any questions of me for 5.5 notes? Any questions of me for 5.5 notes? All right, give me a thumbs up that you're good. Give me a thumbs up that you're good. We won't this week, Tara. Technically, this week is like small group meeting, so I think we're supposed to meet with small groups. Okay. All right. So yeah, not another Zoom meeting this week, but I think you should be meeting with a small group. I'm not 100% sure. Hey, if you have any questions, email me at any time. I'll be on here a few minutes, just in case you want to ask me any questions in the chat box. If not, you guys are free to go. Have a good day. Make sure you do this homework. And then I won't see you guys again until Monday. Monday, we'll go over 5.6 notes. Wednesday, we will have study guide. And next Thursday, you will have a test over Chapter 5, just like the last test. Okay? So make sure you're keeping up with everything. I'll send that schedule out on Sunday so you kind of know what to do. And next week, you will be dropping Chapter 5 stuff off and picking up Chapter 6. Chapter 6 is going to be very short and to the point, and then that will lead us up to our final. Okay? That'll lead us up to our final the last week of May. If you all don't have any questions, you're free to be dismissed. Again, I'll be on here for a little bit just to answer any questions you may have. Thank you, guys. Have a good day. Let me know if you need anything.